Now let's try to minimize this DFA. First of all, it is a DFA, you can check it. For every state there is a transition on small a and small b, and let us assume that this is input given and I have converted it to the table. Then before going further and applying the 0 equivalence, 1 equivalence, this partitioning method, let us see if all these states are reachable from Q0. From Q0, which is initial state, Q1 is reachable, right? And from Q0, Q3 is reachable and Q2 is reachable. What about Q4? From Q0, Q4 is not reachable. In fact, this entire part is not reachable from Q0, which means I could actually delete this entire part. Q4, Q5, Q6, Q7. You just check it. See, arrow is this side. So arrows are coming from this right hand side to left hand side. Nothing is going from this side to that side. Therefore, they will never be reachable from Q0, the initial state. And so I can remove Q4, Q5, Q6 and Q7. So Q4, Q6, these are removed. Now you can simply consider it as 4 states and you can minimize it. What is initial state? Q0. What is the final state? Q3. Q3 is the final state. Okay, so apply the partitioning method. First one is 0 equivalence. Set of non-final states and final states. What are set of non-final states? Q0, Q1, Q2. And what is final state? Q3. Okay, 1 equivalent. Now let us see if Q0 and Q1 are 1 equivalent or not. How can you check it? Take Q0 and Q1 and see their transitions. Q0 and Q1 and see how they are behaving. Right? Q0 and Q1 on small a are going to Q1 and Q0. Both are in same group, Q1 and Q0. And they are going to Q0 and Q2. Both are in same group. Therefore, Q0 and Q1 are 1 equivalent. Q0 and Q1 are 1 equivalent. Now, what about Q2? Now, let us compare Q0 and Q2. Q0 and Q2. Q0 and Q2 are going to Q1 and Q3. Q1 and Q3, which means they are going to different groups. Therefore, Q2 is not 1 equivalent with Q0 or Q1. So, this is what I get. Fine. Now again let us check 2 equivalent. How can I check 2 equivalent? Now see, these two have already been separated and they are the singleton sets in their group. Therefore, I need not check about them. They are saying that we are not equivalent to any of the states. Therefore, I need not check them again. Now let us see these two, Q0 and Q1. Q0 and Q1 on small a are going to Q0 and Q1 and both are in same group. Q0 and Q1 on small b are going to Q0 and Q2. Q0 and Q2, which means both of them, see, Q0 and Q1 on small b are going to Q0 and Q2. Q0 and Q2, which means they are going to different groups in the previous equivalence. Therefore, they are no more equivalent. Q2, Q3. So, in the given question, we have 4 states, and in the minimal automata also we have 4 states. So these 4 states cannot be reduced, and this is the final answer.